Right, quick video, I think, streaming, live. I think you can hear me. Okay, so, oh, stop saying that. Where are we? Jupiter Lab. Done a few things. So I'm going to do a quick recap. Doing the New York City taxi Kaggle thing. Just want to point something out. On my YouTube channel, I've created, so my YouTube channel is youtube.com/Bangford, and I've created a playlist. So there's no kind of one-to-one match between, so sometimes 3 Twitch videos have been merged into one YouTube video, so there are some longer YouTube videos, and also some of the stuff that's in Twitch that's like really long, that's just me waiting for the computer to respond or whatever. Some of that's been cleaned out before I put it on YouTube.
Off to the left of this nature trail that we were on today.
Where am I? I'm gonna pause this. Bigfoot video. Okay, so stop saying that. Wanted to show you that. So the first taxi Kaggle video, I think, was going through, there's like an example that came with the competition, and then shortly after that I went to Maduri Sivalenka's kernel, where she's, what I liked about Maduri's was that she does a lot of EDA, so she investigates the data and looks for patterns and does some data cleaning and all that. EDA is exploratory data analysis, so she does a load of that, and then at the end of it she tries 3 different methods. Now the last time I ran this code, so let me I'm gonna go to my I've got to open up a file. So what I'm gonna do is I need to learn how to do this. I know. Still live? Great. So roughly, my results, doing 1 million rows and basically the same starting point as Maduri, my results weren't quite as good as hers because I'd done a little bit of extra cleaning, which I thought was better, but looks like it's worse on the public leaderboard. So random forest 3.43, light GBM 3.34, XGBOOST 3.61, but then when I did on a million rows, when I did the XGBOOST just with 500 iterations instead of 50, I managed to get the best result out of that either of us had got, and that was only on a million rows. So last night I ran the code with 10 million rows, and I ran the XGBOOST with 2,000 iterations on 10 million rows. So I guess the first thing to do is to go and have a look at how that plays out on Kaggle. Okay, so I ran the code last night at about 8:30. An hour later, at 29 minutes past 9, we got submission 1, which is the random forest. 2 minutes later, we got a light GBM, which I think shows the real advantage of light GBM. 2 minutes later, we got a result. An hour and 10 minutes after that, we got the XGBOOST that was ran on 2000 iterations. And just while we're here, and while I remember, sometimes you can get a better result. So now we've got 3 sets of results from 3 different methods. One thing we could do is average those results, or average the squares of those results and square root them, or we could do something like a GLM or some other model using these results as a factor, and I've seen that done before and get even better results. So all this stuff's coming back to me now, which is great, which is why I think it's really good to do this exercise, because I'm learning Python at the same time as remembering some of the things from a previous role. So let's take these and see how they do. Okay, so we can clearly see we've got a 10 million comparison. We use 10 million rows from the training data set. We've got a submission for Forest, a submission like GBM, and a submission XGB 2000. So let's go back to the spreadsheet. This makes such exciting viewing, eh? Yeah. I got high hopes for this run, you know. Okay, so we've got the output. All we got to do is put it on Kaggle. Let's do it. Right. Competitions. Taxi fare. It's a weird thing. Competitions. House prices, New York City. Once upon a time I entered the All-State competition, but perhaps because it's not current. Okay, let's go. Python. Kaggle. Taxi. Output. 10 million. Random forest comes first. Now I think I've tested this before. I've got 10 submissions remaining today. That's confusing. Okay, so, right. Yep. Briefly describe. Okay, random forest 10 million. Make submission. Checking that Bayes' theorem is still true. Not an improvement. So 3.18, which is quite good. It's quite good. paste special values. I'm going to take off the conditional formatting. Right, so what we're seeing here is that for random forest, if you use 1 million rows of training data, you get 3 point... This music's too loud. I'll turn it down your end. Oh, I hate that noise. Okay, so random forest, you use 1 million rows in the training data set, you get 3.44 on the public leaderboard. Lower the score the better, because it's like an error. It's an error, so I can't remember how many rows, but we're basically uploading a load of results, and those are being compared with the actual, because we're talking about actual taxi journeys, and those actual taxi journeys, they have a fare that's known, but not known to me. It's known, it's sitting on a server somewhere at Kaggle. So when I upload my results, they compare my prediction of the taxi fare with the actual taxi fare that was charged for that journey. And I'm trying to derive that taxi fare from a few factors. And let's just go and have a look at what those factors are, because I'm sure we've got headings very close to the bottom here. Where are they? What's in my training data set? I saw this yesterday. It was... There's a table. Here's a table full of data. So we've got pickup date time, pickup longitude, latitude, drop off longitude, latitude, passenger count, distance of the journey, year, month, date, day of week, and hour. So all of those, we think they're all factors in predicting how much a taxi driver is going to charge for a taxi ride. Now this was an interesting one, just going to point it out while it whizzes past. We found out that there's 0 passengers, so that was something that got cleaned, I can't remember how. 1 passenger is where you get the highest prices, and as the number of passengers comes down, the taxi fare comes down. I wonder what would happen if you looked at that versus distance. Is it that when people are on the really longest journeys of people on their own? I don't know. You can speculate forever with these things. Quite often, I think, probably wrongly. Okay, so we've just had a go at random forest, and we got a really good score. It's very close to an XGBOOST on 500 that we did yesterday. So what's happening now? We do another one. So this time it's light GBM. Yeah, it's Google Chrome's software reporter tool. Getting distracted. I've seen it before though. LGB. Light GBM 10 million rows. Make submission. Checking that Bayes' theorem is still true. Oh, which is terrible. 3.31807. So, an interesting thing happens then. Am I right? That is super weird. So, the random forest, when you use 1 million rows of data, light GBM performs better than the random forest. But then when you add 10 million, you add another 9 million rows of training data, light GBM gets slightly better, but the random forest gets way better. Isn't that interesting? So right now, our winner on 10 million is random forest. But I've got high hopes for XGBoost 2000 iterations. This is going to be, I think it's going to be epic. I really do, because on 1 million rows with 500 iterations, we've got 3.14. So, 3.15. I just, everybody wants, what a great number. Okay, so here we go. XGB 2000. Yep. Let's go. Wiring more money. It's too fast. No. 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 This is weird. It's very interesting. Overfitting? So the best result of 3.15 was achieved using 500 iterations of XGBoost on 1 million rows of data. So my gut feel now is go back to that, use that as a starting point and experiment with some other things. And I'm just going to talk about one other thing that came up. I'm sure that I read in one of the kernels or one of the comments about there's more of the older data in the training set than there is in the test data set, and that's certainly for 2009, that's certainly true. And the other thing that you can see in the data is almost that there was a step change, and I think it happened at some point in 2010 or 2011, I can't remember now. I did a good, yeah. I feel like you can almost see that at some point in 2011 there was a price increase. Now, my thoughts on this, somebody was suggesting that perhaps if you throw away these 2 years, you can build a better model. But I'm thinking that things like XGBoost and probably random forest, all three methods, well, they're going to take account of interactions, and they're essentially building a model that has year as a factor. So I'm not sure of that, but of course it's something that we could experiment with. So what I'm going to do, I might stay live for a little bit longer. N rows. 1, 2, 3, 4, 5, 6. So 1 million rows. And let's go back to 500. Let's make the XGBoost. Numrands 500. You know what? When I click to run this, it's just going to run forever. So I've been live for nearly 20 minutes. That makes a reasonable YouTube video, which I hope is useful to someone. So I'm going to leave it there. And we're going to need some nice ending music.
Every day I imagine a future where I can be with you.
This is the music from Doki Doki Literature Club, for anybody who's not familiar, which was a horror game masquerading as, I don't know, like a romance simulator or something, but it's actually a horror game.
Just move your hand right the way into his heart. But in this world of infinite choices, what will it take?
That's not
just
good.
To find that special
Right,
day?
that seems like a good place to end.
What will it take just to find that special day?